In this video, we're going to look at the volume of a frustrum and also the surface area of a frustrum. So a frustrum is basically when you cut a cone so that you get a smaller cone and a larger cone. So in this question, we can see the smaller cone has a perpendicular height of 3 and the larger cone has a perpendicular height of 3 plus 3, which is 6. So let's start off by drawing the larger cone out first. So I've got the large cone here. So it has a radius of 8 centimeters and a perpendicular height of 6 centimeters. So what we're going to do is say, well, it forms a right angled triangle. So I want to work out L. So I can work out L by using Pythagoras. So that's going to be 6 squared plus 8 squared. So L, the slanted height for the large cone, will be 10 centimeters. Now let's draw out the smaller cone. So the smaller cone, we've got, well, we need to figure out the scale factor here. Well, if the perpendicular height of the large cone is 6 and the perpendicular height of the smaller cone is 3, we can say the scale factor is 6 over 3, which is 2. So it means the larger cone is twice as big as the smaller cone. So if the radius of the large cone is 8 centimeters, we can say the radius of the smaller cone is certainly 4 centimeters. And don't forget the height, the perpendicular height of the smaller cone is 3 centimeters. So let's use Pythagoras again to work out the slanted height. So it forms a right angled triangle. We want to work out L. So it's the square root of 3 squared plus 4 squared. So L is 5 centimeters. Okay, we're going to need that for the next part of the question. So the first part of the question says, show that the volume of the frustrum is 112 pi centimeter cubed. So we just do the volume of the large cone, a third pi, times the radius, which is 8 squared, times the perpendicular height, which is 6, minus a third pi times the radius of the smaller cone, which is 4, times the perpendicular height, which is 3. So don't forget, this is non-calculator. So I make my 3 a bit more legible. So it is a non-calculator paper. So we're going to say, well, I'm going to cancel 6 and 3. So that'll give me 2. Cancel the third and 3 to give me 1. So now I can get 8 squared is 64 times 2 is 128. That's 128 pi. Minus, well, 4 squared is 16 times 1 is 16 times pi. So we get 16 pi. So we're going to do 128 minus 16. So that will give me 2, that will give me 1, and that will give me 1. So I get 112. That's exactly what they want me to show, that I get 112 pi centimeter cubed. That's the volume of that frustrum. Now part B says to find the total surface area of the frustrum. So what's happened? We've got, so if we think about our frustrum, we have a circle on the top, we've got the curved surface area on the outside, and the circle on the bottom. So what I'm going to do, I'm going to shade the curved surface area in red. And that's what we're going to do first. Well, that's just going to be the curved surface area of the larger cone minus the curved surface area of the smaller cone. So we're going to do that. We're going to have pi times the radius of the large cone, which is 8, times the slanted height of the large cone, which is 10, minus the curved surface area of the smaller cone. So it's pi times the radius, which is 4, the slanted height, which is 5, and then we can say that's going to be 80 pi minus 20 pi. So the curved surface area of the frustrum is 60 pi. So I'm going to write that as curved surface area of the frustum. Okay, so what else do we need to add? Well, it has a circle on the top and a circle on the bottom. So the area of the circle is on the top is going to be the circle of the smaller cone. So that's going to be the radius of the smaller cone. So it's going to be pi times 4 squared. And we need the area of the large circle on the bottom, and the radius of that is 8. So it's pi times 8 squared. So that's going to give me 16 pi plus 64 pi. And that will give me 80 pi all together. That's of the two circles on the top and the bottom. So all we do now is we do 80 pi plus the curved surface area in red, which is 60 pi, and that will give me 140 pi centimeter squared. Here's a question for you to try. You can pause the video, and when you're done, I will go through my worked solution. Okay, welcome back. So what we're going to do is say, right, we've got a cone here. It's been cut to make a frustrum. So we're going to say, right, well, we've got the radius of both of them. So, and we've got the perpendicular height of both of them. So it's going to be the volume is simply going to be 1/3 pi times the radius of the large cone. Be careful, it's 7.5 because it's half of 15, times the perpendicular height, which is 30, minus 1/3 pi times the radius of the smaller cone, which is 2.5, squared, times the perpendicular height, which is 10. Type it into my calculator. So now we could type it in our calculator. So we get 1/3 times pi times 7.5 squared times 30 minus 1/3 times pi times 2.5 squared times 10. And we're going to round our answer to 3 significant figures. So don't forget, this rounded to 3 significant figures is going to be 1700. So we get 1700 centimeter cubed.